Today, we're diving into the fascinating world of space weather and exploring how the sun, despite being 150 million kilometers away, can have a profound impact on our lives here on Earth. From electricity networks to transportation, the sun's influence is far-reaching and sometimes alarming. You might be wondering, what exactly is space weather? This scientific discipline studies the complex interactions between the sun and Earth, aiming to understand, quantify, and predict how solar activity affects our space and terrestrial infrastructures. But what are these risks, and how can the sun impact our daily activities? To understand the potential dangers, we need to go back to the Carrington Event of 1859. During this event, auroras were observed at very low latitudes, far from their usual polar regions. Despite the limited technology of the 19th century, telegraph systems were significantly disrupted. They continued to send information even when powered down, a phenomenon dubbed celestial batteries. This was due to electric fields generated by the auroras. Other significant events include the 1989 blackout in Quebec caused by a massive solar storm, and the Halloween storm of 2003, which left the town of Malmö in southern Sweden without power. The root cause of these disruptions is always the same: solar storms and their interaction with Earth. The sun constantly bombards us with electromagnetic radiation and particles known as the solar wind, which are primarily electrons and protons. When large solar flares occur, massive quantities of plasma are ejected in events called coronal mass ejections. These plasma bursts can penetrate Earth's magnetic field, leading to geomagnetic storms. When these charged particles interact with the molecules and atoms in our upper atmosphere, they create the luminous phenomenon known as the polar aurorae. These beautiful displays are visible evidence of the Sun-Earth interaction. But the effects of geomagnetic storms go beyond stunning. Power grids can be severely affected by geomagnetically induced currents, leading to disruptions and even blackouts. Pipelines and rail networks are also at risk. The aviation sector can be impacted by high-energy particles from coronal mass ejections, potentially causing damage to aircraft systems and increasing radiation exposure for passengers and crew. Everyday devices like mobile phones, connected watches, and cars rely on satellite positioning systems, which can be disrupted by geomagnetic storms. This can lead to accuracy errors and position shifts, causing significant problems. These disruptions can have serious economic and social consequences, as our interconnected systems depend heavily on reliable power and communication networks. A prolonged blackout could have cascading effects on infrastructure and daily life. So, how prepared are we for such events? Governments and the space weather community are taking these risks seriously. Preventive measures and accurate predictions, like those from NOAA, have helped mitigate damage in past events. For example, on May 10, 2024, NOAA's timely predictions allowed operators to limit the impact of a solar flare. However, future solar flares that are more severe or less predictable could cause far more extensive damage. This highlights the importance of continued research and preparedness in the face of space weather. Stay tuned to Space Vanguard for more insights into the mysteries and marvels of space.